Hi everyone, my name is Wijdan Amakhchan. I am a PhD student in Geoinformation and Territorial Management Unit Laboratory at Abdelmalik Saad University. I'll be presenting the paper titled Automatic Filtering of LiDAR Point Cloud Using MultiLayer Perceptron Neural Network. Two research teams from Abdelmalik Saad and the Southern Queensland University share their knowledge and data to release this research. We will start the presentation with the general context, the input data. After that, present the method and the results obtained, then finish the presentation with a conclusion. The machine learning-based approach for LiDAR data filtering represents a hot research subject that can profit from all available rule-based approach. So first, what is LiDAR? LiDAR, or light detection and ranging, is an active remote sensing technique. The idea behind LiDAR is quite simple. Is to point a small laser at a surface and measure the time it takes for the laser to return to its source. There are many types of LiDAR, and choosing the right one is crucial for its successful usage. Here are outlined some types of LiDAR. Terrestrial LiDAR is a system that works on the ground. Mobile LiDAR is placed on the top of a moving vehicle such as a car or a train. Airborne one is placed either in an aircraft or the helicopter. Satellite LiDAR is set up in a satellite that revolve around the Earth, etc. We use airborne data in our paper with the machine learning, which is an artificial intelligence technology that provides systems the ability to automatically learn and improve from experiences without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn from themselves. There are several algorithms used in machine learning, and we adopt multi-layer perception classifier in our research, which is a supervised learning algorithm belonging to the family of feed-forward neural network that transfer the information in one direction from an input dataset to a different set of outputs. It consists of input layers, hidden layers, and output layers. The activation function determines the behavior of the node. It combines the input features and their weights plus a bias term. We also have calculated the feature values of each point using different combination of eigenvalues and the covariance matrix of a point to calculate the normal vector and the roof characteristics of the noisy Wijdan roof point cloud. So the objective of this research is to develop an approach that automatically filters the Wijdan point cloud using machine learning multi-layer perception technique applied directly to the non-manipulated Wijdan point cloud. As you can see in the figure, it shows an example of Wijdan from our input LiDAR point cloud that contain several classes: vegetation, terrain, Wijdan, and remained points. The input data used in this research is 3D point cloud of Vaihingen city in Germany. This data is provided by International Society of Photogrammetry and Remote Sensing in the Benchmark project. The point density is between 4 and 6.7 points per meter square. The general workflow of our method is to firstly label the input data by splitting it to roof and non-roof point, and attribute a specific code to each class. 1, for example, 1 to roof points and 0 to non-roof points. Secondly, split the data into training and test sets. After that, create the model using multi-layer perception classifier and train and validate this model using our training set. And finally, test the model on the test set to estimate the accuracy of the model. If it was a good accuracy, then we can pass to the prediction. If not, we change the parameter and reapply our model on the train set. To sum up, the process adopted in this paper. We select 50 buildings randomly from 70 building LiDAR point cloud. Then, in the first step, we have applied directly. We have directly attribute a specific code to each class and then split the data set into training and test set. After that, create the model using multi-layer perception and train and validate the model. Then we have estimate the accuracy of the model. In the second a second step, we have calculated the feature values of each point and group the results in a matrix, and then repeat the steps 3, 4, 5, and 6 to finally test the model and estimate the accuracy. This is the result obtained after applying the model on our input data. This represents the extracted roof of noisy building point cloud. And in the right, we have the extracted non-roof of noisy building point cloud. It contains the vegetation, the terrain, point cloud, and the remains point as well, with an accuracy equal to 0.51 estimated to the model while using it directly to the coordinates only, and with an accuracy equal to 0.81 while using the feature values. So to sum up, the paper suggested a new approach for automatic filtering of LiDAR built-in point cloud using multi-layer perception neural network. The suggested machine learning approach was applied directly to the noisy building point cloud without any interruption or data reduction, and showed a promising result with a score equal to 81%. With that, we have achieved the objective of this research. So for our future work, the suggested algorithm can be extended to classify city point cloud. We have arrived to the end of this presentation. I would like to thank you for your attention.